Welcome to the deep dive. Today, we're cracking open a document that dissects a real heavyweight in the AI world, the RoBERTa language model.
That's right. And our mission really is to cut through some of the technical jargon, focus on what RoBERTa changed compared to, its famous predecessor, BERT.
And figure out what that tells us about building these kinds of powerful AI models.
Exactly. Uncover those core insights.
Okay, let's unpack this then. So RoBERTa, at its heart, it is a variant of BERT, right? From Facebook AI.
Yep. It keeps that same transformer architecture, the self-attention mechanism, all the stuff that made BERT so revolutionary for understanding language context.
But the document we looked at suggests the real difference wasn't the architecture itself.
No, not fundamentally. The source is pretty clear. The magic, the performance boost, it really came down to how they trained it. They pushed the boundaries on the training methodology.
Right, that's where it gets fascinating. The document highlights several key optimizations. Looking at the source, what felt like the biggest single change they made?
Well, you just can't ignore the sheer scale of the data they used. RoBERTa was trained on, get this, 160 gigabytes of text.
Whoa, 160 gigs. Okay, put that in perspective for us. How does that compare to BERT?
That's the kicker. It's more than 10 times the data BERT was trained on. It really showed that feeding the model significantly more high-quality data can lead to pretty dramatic gains.
If you do it right, yeah.
If you do it right. But like you said, it wasn't only about throwing more text at it.
No, the document mentions they tweaked the training process itself. They actually removed something BERT used called the Next Sentence Prediction Objective, NSP.
That's it. NSP was basically trying to teach BERT if two sentences likely followed each other in a real document.
Why get rid of that? Seemed logical enough.
Well, the thinking was, based on the results they saw, removing NSP simplified things. It let RoBERTa focus more, perhaps, on understanding the relationships within sentences and paragraphs via masking, rather than dividing its attention trying to figure out the relationship between separate text chunks.
Okay, interesting. And sticking with scale, it wasn't just data volume. They also went big on the training mechanics. Specifically batch size. The numbers seem pretty wild.
Oh, they were. BERT typically used batches of, say, 256 sequences, RoBERTa. They started with 2,000 sequences per batch and even pushed it up to 8,000.
8,000 sequences at once, compared to 256.
Yeah, imagine processing 8,000 examples in parallel for every single training update. It's a huge difference in scale.
And the source explained the benefit of going that big.
It did. Several advantages, actually. Using these massive batches improved the model's internal language modeling ability. You see that in better perplexity scores, which kind of measure how well the model predicts the next word.
Lower is better, right?
It's
less surprised.
Exactly. And crucially, it led to better accuracy on the actual downstream tasks, the things people use these models for. Plus, there's a practical side. The source notes that large batches are just much more efficient for parallel processing on lots of hardware. Makes training on 160 gigs feasible.
So more data, refined training goal, massive batches. Anything else on the masking front, that core BERT idea?
Yes, one other really key optimization. Dynamic masking.
Dynamic masking. How's that different from what BERT did?
BERT used static masking. Basically, the words to be masked were chosen once during data prep, or they'd duplicate the data a few times with different masks. RoBERTa, though, changed the masking pattern every single time the model saw a particular sentence during training.
Okay, why bother doing that? Seems like extra work.
It forces the model to learn better. If the mask is always changing, it can't just sort of memorize patterns related to where the mask is. It really has to rely on the surrounding context to figure out the hidden word. Makes for more robust, generalized understanding.
Gotcha. So you combine all these things. The massive data, dropping NSP, huge batches, dynamic masking. What did the source say about the results, the performance?
The results were pretty definitive. RoBERTa significantly outperformed BERT and other top models at the time on a whole range of standard NLP benchmarks mentioned in the source, things like text classification, question answering, even some translation metrics.
And that success obviously resonated.
Absolutely. Because it performed so well right out of the gate, it became a really popular starting point, a base model for tons of subsequent research and development in NLP. You still see it used widely in both academia and industry.
And just to connect it back for you listening, understanding why RoBERTa works so well, these careful optimizations in training and scaling, it kind of demystifies some of the magic behind the AI tools you interact with, maybe without even realizing it. Better search results, smarter assistants, that sort of thing.
Yeah, to sum it up quickly, the source really highlights that the jump from BERT to RoBERTa wasn't about reinventing the wheel architecturally. It was proof of the power of massive data scaling combined with smart, detailed optimizations to the training process itself. Removing NSP, the huge batches, dynamic masking, those were the crucial ingredients documented.
So as we wrap up this deep dive, it really makes you wonder, doesn't it? If these kinds of meticulous training refinements on an existing structure like BERT gave us RoBERTa's boost, what's the next frontier? What kind of fundamental shifts in how we train these models might unlock the next major leap in AI language power?
And how would that change the AI we all use every day? Definitely something to chew on.